Good morning, class. Today you get to become experts on high-speed trains. So turn in your books to page 100. Once you're there, you can see a photograph of a very fast-moving train. I'll give you just a second to find it. Alright, so let's start learning about high-speed trains so that we can be experts. Our heading says high-speed trains. Our passage says, trains were once the fastest way to get around. In 1869, a train took 6 whole days to cross the country. The speed that train could move would seem slow now. Today, it only takes 6 hours to cross the country in a plane. So it used to take 6 whole days to cross the country in a train. Now we can do it in 6 days. 6 hours. That's a big difference. Now, remember that the speed of the train is the distance it moves in a period of time. So let's look at this little photo insert of a steam engine. That's what older trains looked like. And our caption on it says, steam engines were once used to make trains move. So they used to use steam to make the train move. That was its energy source. Alright, let's look at page 101. It says, train engines are in special cars. These cars are at the front or back of the train. The engine provides the force that moves the train. A large force is needed to move a train. Well, that makes sense. They're very heavy. Early trains had steam engines. In the 1930s, new train engines that used diesel fuel were used. Many trains still use these types of engines today. Other trains use electricity. So diesel fuel is kind of like gasoline. It's what the big trucks that you see on the road use to move. So let's look at the inserted photograph in this page. This train looks a little newer than the train on the last page, but it's still pretty old. Our caption on this one says, people have ridden trains to get where they need to go for many years. Now we need to remember that the engine provides the force that moves the train, and a force is a push or a pull. So the engine pushes or pulls the train, depending on if it's in the front of the train or the back. Now let's turn the page and look at page 102. Our heading says, bullet trains. Our passage tells us that some trains move very fast. They are called bullet trains. Some of these trains have a top speed that is over 320 kilometers or 200 miles per hour. Most of these trains have electric engines. How does a train get electricity while it's moving? There are wires above the train tracks. The trains have special parts on top. These parts allow the train to get electricity from the wires. In this way, the train can get electricity while it is in motion. So it can get electricity while it's in motion, which means that it can get electricity while it moves down the tracks. Now, let's think about how fast 200 miles per hour is. Most highways have a speed limit of 70 miles an hour. So when you're driving down the highway, you're driving about 70 miles an hour. These bullet trains can move 200 miles an hour. That's almost 3 times as fast as you move in the car on the highway. That's a really fast train. So let's look at our insert of a photo of a bullet train and read the caption. It says, this train gets electricity from wires above the tracks. Well, that seems pretty cool to me. Alright, let's look at page 103. It says, the Acela train is the fastest train in the United States. It takes people between Boston and New York City. It also goes between Washington, D.C. and New York City. Its top speed is about 240 kilometers, or 150 miles per hour. It only goes this fast where the train track is straight. It slows down when the track changes direction. It's probably a good thing that it slows down. I don't think I'd want to be going 150 miles an hour and have to turn. So let's look at our caption. It says bullet trains help people get from place to place faster. So, bullet trains help us move more quickly from one place to another. That sounds like a good thing to me. Let's look at page 104. It's about something called a maglev train, which is what our heading says, maglev trains. Some of the fastest trains in the world are in Germany. One of the trains, the Transrapid, can go up to 434 kilometers or 271 miles per hour. This train is different from electric trains. It doesn't have an engine car. It doesn't even have wheels. It glides on a thin cushion of air above the tracks. The train is a maglev train. The word maglev is short for magnetic levitation. These trains are called maglev trains because the force of magnetism lifts them above the tracks and makes it seem like they are floating. So, the magnets on the bottom of the train must have the same pull as the magnets on the track. They're repelling each other. So those would have to be some pretty strong magnets to hold a whole train up in the air. But magnetism can help us move very, very fast. So let's read our caption. It says, maglev trains move on special train tracks. Alright, page 105 says, a train floating in the air might seem like magic. After all, trains are big. They are very heavy. The pull of gravity on the train is strong. So gravity is trying to pull the train to the ground. It wants it to go to the center of the earth. Let's keep reading. It says, of course, it is not magic. The magnets keep the trains up off the track. The magnet's pull is greater than the pull of gravity. These magnets keep the maglev train riding safely on the thin cushion of air above the tracks. So if we look at our insert, we can see an illustration that helps us to understand what's happening. And we have a caption that says, the magnets on the train go under the track. The pull between these magnets lifts the train up. Wow, that sounds pretty interesting. I'd like to see that in person. So let's look at page 106. Maglev trains use special tracks that have coils. The coils are turned into special magnets that use electricity. The magnets are only turned on when the train is nearby. The magnets in the track push and pull on the magnets in the train. These pushes and pulls move the train forward and stop the train as well. Friction is not a problem for maglev trains. So, it doesn't slow the maglev train down. Why? The trains do not rub against the tracks. They float above the tracks. Without much friction, the trains can go very fast. Remember that friction has to be touching. The two objects have to rub together. So our insert has a caption on it that says, there is almost no friction between this maglev train and the track. So because there's no friction, the train can go much faster than, say, a car on the highway. Alright, and let's look at our last page, page 107. Our heading says the future of maglev trains. Our passage tells us that maglev trains have a lot of good properties. They do not make noise. They ride from one place to another The ride from one place to another is very smooth.